This is a level 3 question. All I want you guys to do is read the question, try to figure out what is given, and try to put it as a diagram. That's it. Okay guys, so please pause. I hope you guys tried. Let me put it as a diagram. So what is that we are looking at? We are looking at a free body diagram of the stone when thrown. Of the stone when thrown. It rhymes. Okay. So let us draw the stone. Let us talk about the force that is acting on it. Only one force, that is gravitational pull. It is accelerated downward with 10 meter per second square acceleration. Why negative minus 10? Because we're taking up as positive direction. Okay guys, so this is your free body diagram of the stone when it's going up. Why is that I'm taking two different cases? I'll explain. A ball is thrown vertically up and returns to the thrower after 6 seconds. Find the velocity with which it was thrown up, the maximum height it reaches, and the position after 4 seconds. It's a bit weird question, is it not? So we have the object reaching a certain point. It was initially thrown with the velocity of something, we don't know that. Time t is equal to 0 second. At the peak, what happens? It reaches with the velocity of 0 because it comes to rest, so it will be 0. The time is not to be found. No, we have time. That is actually important. Where do we have the time? I'm telling time is there. Where do we have the time? That's my question. A ball thrown up returns to the thrower after 6 seconds. What does it mean? See, object is going up and coming down. Okay, let me show you guys that. So the ball is thrown up, it goes up and comes down. So for this entire journey of going up and coming down, it takes 6 seconds. But just for going up, how long will it take? What do you guys think? Just for going up. Yes, 6 by 2, that is 3 seconds. Okay guys, that calculation we have to show. I'll write it over here. I have enough space. Time to reach the top is equal to time for entire journey divided by 2, and so that is 3 seconds. Then we have acceleration, that is 10 meter per second square, that is pointed downwards. Then what else we have? I think that's it, right? Agree? I'm just reading the question. Yes. So they're asking the velocity with which it was thrown. So we have to find u, maximum height. So let me mention that also. How much is your height? And what else? That's it. Okay, let's begin. Now the working. Again, from this point onwards, you guys have to pause. Everything is given. Everything is drawn. Now you guys have to figure out the answer. It's quite simple. All the three are quite simple. The third one is difficult. This is difficult, that I'll mark it off. First two, you guys can find it without my help also. Please do A and B and try the C one. If you guys get it, very good. If not, it's okay. Okay, let's figure out what formula can we use. Velocity with which it was thrown. So V is equal to U plus AT. Will this help? It helps. We know V, we know U, we have to find U, E and T we know. So final velocity is 0, initial velocity is U minus 10 into 3 seconds. So U is equal to 30 meter per second. That's it. Next is maximum height it reaches. So we have to figure out h. How will we find that? S is equal to ut plus half at square. I think this will help. So we have S is equal to 0 plus half into minus 10 into time square is 3 square. So clearly this is 45 meters. Okay, that is done. Now the question is difficult. Its position after 4 seconds. See, at 4th second what happens? See, I'll do this. This was 0 second. This is 3 seconds. And at the 4th second it will be somewhere along the way. So we have to figure out what is this position. Okay guys, so let me do this. This is what we have to figure out. This is for question number C. I'm not marking it as A, B and C because anyways the point is final answer. If you write it in an orderly manner, that's good enough. But yeah, here I'm indicating. For now we have to just ignore this. Let me actually, I'll explain it. Just a second. I'm just trying to find. Yeah. Okay, guys. This is good enough. So this was t is equal to 0 seconds. T is equal to 3 seconds. T is equal to 4 seconds. It will be coming down, right? So where is it is the question. Obviously it's between 0 to 45. But where? How do you figure that out? To do this, let's begin with free body diagram of the stone falling down. That's all. That's the only trick over here. If you understood this, you're done with such questions as well. So we have the object. It's coming down. It's coming down. And the force that is acting on it is only Fg. And we have the acceleration due to gravity as positive 10. Reason being, since it's falling down, I'm taking down as positive direction. And yeah, time is, okay, time here is 1 second. Because from 3 to 4, the time difference is 1 second. Is it not? Right? So the question is, where is the object at 4th second? So we can calculate it this way. We can name it as A, B and C. Okay guys. So we have to figure out BC. BC, we can find it with the help of ut plus half at square. What is the initial velocity over there? Initial velocity of what? Initial velocity from 3 to 4. Why is that the initial velocity? The thing is, we are just considering the falling. Where will the fall start from? The fall will start from this point. So that would be a new time. You know, the original time is 0, 3, 4, somewhere 5 and the 6th second is something like this. But for the fall, the diagram would look like this. This is 0. Okay guys. This would be 1. Somewhere along the line it's 2 and this is 3. At the 3rd second, the person holds the stone again. I hope you guys understood this. This is very important. See, till now whatever we've done is quite simple. Now this part is the one which is confusing for many. Okay, so actually I should be drawing a separate diagram so as to clear things up. Okay guys, just let me do that. I'll just replace all of this, matlab, I'll just cut and I'll write it neater so that you guys can understand later. You don't need to do so much actually, just that things will be a lot clearer, right? Making things clear in your notebook is the key. Everything else during the exam will work out. If you understood something and if you revised good, things will work out. Not an issue. Okay, I think this looks good enough. Right? Stone falling down. Heading this mentioned, and we have the diagram over here. So what will I do is, this is our original time. That's our new time frame. Okay, so if I consider this as 0, right, wherein u is equal to 0 meter per second, because it just reached the top, is it not? So it has to have 0 meter per second velocity. Within 1 second, we don't need to know the velocity, but we have to figure out the distance. And this will be at 3 seconds, wherein it reaches the ground. Okay guys, or the person's hand. You understood now? The original time frame is 0, 4, 0, 3. Again, he is falling down, remember, this is falling down. Not going up, falling down. 4th second, somewhere along the line is 5th second and 6th second. But if I consider the time to start from the point wherein the rock is at the highest point possible, so that would be your new 0, and within 1 second, where is it is what we have to figure out. If you are able to figure that out, everything else will fall in place. So I'll start the calculation over here because I have limited space, and yeah, I have limited space. I have a different question over there. So I'll just try to do it over here. Okay, let me do that. Yeah, now what is that we have to figure out? I have to find BC. So BC is equal to S, right? We can use that formula, ut plus half at square. At square by 2. This is equal to 0 plus, here it's plus 10, remember, because down is what we are figuring it out for. It's falling down, is it not? So down is positive, so A is positive, time is 1 second, square of that is also 1. So it has reached 5 meters down. But we have to find AC, right? AC is what we have to actually figure out. Therefore, AC is equal to AB minus BC, that is 45 minus 5, that is 40 meters. Agree? And end of it, we have, end of this, we have the summary of everything. The initial velocity is equal to 30, the maximum height is 45, and the position after 4 seconds. Initial velocity is 30 meter per second. Maximum height is 45 meters, and after 4 seconds, or at 4 seconds, it is 40 meters above ground. We need to talk with reference to something. So above the ground, it is 40 meters, right? The reference being the ground. That's why I subtracted over here. Okay guys, if not, if you had some other reference, you can talk from that point of view. So this is again relative, position is also relative. I spoken about relativity, right? A bit introduction in the first chapter. So it's in continuation. Everything is a continuation. Remember that. Okay. I hope I didn't confuse you guys with the last bit. All we are trying to do is 4 seconds is what we have to find where the object is. So in this case, since the object is returning, we can't take the reference as the initial one, t is equal to 0 from here. It'll be a bit difficult to think forward, do the numerical and handle all of this scenario. So it's best to go with taking from the top, where is it at that point, right? From the top, after 1 second, it's at point C. So what is the length of BC is what we have to figure out, and we did. And after that, you have to figure out AC. That's it. Okay guys. So this is all in all your answer. It's a good question. So see to that you guys mark whichever is important, like points. Question number C is very important. And as a whole, this question is important. That's why I put level 3. So see to that you guys put all of this indicators so that you guys revise before your exams. Okay. So now I think we don't need this. Yeah. Pause and copy everything, and neatly. It has to be neat.